Professor Penrose singularities in black holes are big mathematical discovery. But now the question today is if this discovery has also a physical meaning. That means that if these singularities exist also in physical reality. We know that Professor Penrose singularities are somehow development of the geometrization of gravity, of general relativity inside the black holes. So the main question is what is happening inside the black holes, in the center of the black hole. And Professor Penrose is proposing that in the center of the black hole, in the center of the black hole, so-called space-time is so curved. Here is a black hole that because of this huge curvature happens in the center of the black hole, that the value for the gravity force there is infinite. We have infinite gravity there. Now, so far so good. This is okay from the mathematical point of view. What about from the physical point of view? There are few troubles. The first and the most strong is that NASA has measured back in 2014, NASA has measured that Euclidean space, that universal space has Euclidean shape. What does it mean? They measure angles between three stellar objects, and they find out that the sum of the angles is always 180 degrees. This means that universal space is flat, has Euclidean shape. Since then, it is not the best idea to talk about the curvature of space because we all know that the curvature of space is only a mathematical model and that universal space is flat, has Euclidean shape. So, on the basis of this curvature of space inside of black holes, this idea of Penrose singularities was developed. But if we look black hole from another perspective, from the perspective the black hole is a huge amount of mass which is in the universal space, which is flat, which has Euclidean shape, then we could apply a Newton's shell theorem to understand what is happening inside of the black hole. And in the Newton's shell theorem, we know that if we go inside the stellar object, from here we go to here, then the gravity there will diminish exactly for the amount of the shelf. Okay. So if I'm measuring gravity on the Earth here, I will get usual gravitational acceleration. If you go inside here, let's say 10 kilometers, then I will measure less, and this less will be for amount of this matter mass here. Okay. So black hole from this perspective is nothing else than a huge amount of mass which is incorporated in a physical object and can be studied from the perspective of the Newton's shell theorem. And when you study black holes from this perspective, then you got another model where it's happening that in the center of the black hole, energy density of space, of universal space, which we call today superfluid quantum space, is so low that atoms become unstable. So according to this model, when we are in the center of the black holes, It's not that that gravity there is infinitely big. There is no infinity at all in the black holes, but the gravity there is zero. But something else happened because space is so the density of space is so low. Atoms atoms become unstable and fall apart into elementary particles, which are then thrown out in these big, huge jets into intergalactic space. This is our proposal, which somehow is less, let's say, exotic than the proposal of Professor uh, Penrose. Our proposal has a physical meaning, and proposal of Professor Penrose has only a mathematical meaning. So this is it. Article is published, and I welcome you to read the article and to send us your comments. Thank you very much.